This is the CTRLDock, a super low latency analog and digital vintage controller to USB interface for PC, Mac, Linux, your RetroPie, Mister and a whole lot more. And it's available now thanks to the boffins downstairs. And one of those boffins is right here with me. It's Richard from Heber. Thank you for joining us, Richard.
Thank you, Neil.
You've come all the way up the stairs.
All the way up the stairs,
to show us what's called the CTRLDock. Here is one such example because it comes in three forms, which we'll cover today. But let's just start with the basics. Why does this exist, Richard?
It exists, Neil, because we were asked a lot of times for interfaces to classic controllers. Mm-hmm. And I think when we looked at what was available in the marketplace, we weren't really that happy with some of the controls, some of the products that are out there, the latency on them, and we wanted to do a better job. So we thought, why not at least start with the D9 and the D15 because they cover quite a wide range of controls.
So this is one such example of a product. I'm not picking this one out for any other reason than it's the one that I've got. This is a Mega Drive controller adapter, which I think I got it off of Amazon several years ago. It did the job. I could plug my Mega Drive stick in, digital only, so it had no analog support for things like mice, trackballs, spinners.
As you say, it works. I'm not even sure whether it worked with the 6-button pads. Can't remember whether we checked that. But yes, it does actually function as an interface for a control, but very slow, very low, very long latency on the controls, which basically means lag between you pressing the button and something happening on the screen. We also found that there was quite a lot of variable latency, and this was up to sort of 40, 50 milliseconds, which is a very long time when you're trying to play an action game or even a platform or whatever else. So quite significant amounts of delays in the USB bus.
Compensated perhaps by my middle-age reaction times, but when you put it to the test, you find that it's not actually that great, but it's also not that expensive. So you kind of get what you pay for with these products.
Yes, they're cheap and cheerful, and they do work if all you want to do is plug in your control and just about make them work.
So you came up with a bit more of a premium product, a bit more of a quality product, and tell us what's on the board, because we've got the bare board here.
So first thing we had to decide was what microcontroller to use, and during the pandemic there's obviously been a lot of problems getting hold of any sort of microcontrollers where you need lots of inputs and outputs and controls. We ended with the Raspberry Pi, so the Pi Pico is a really nice little module. You can buy the raw chips on their own and put them down on the board, but actually the little SPI flash that comes on the Pico module is quite expensive on its own. So those modules work out to be quite good value for money, really. So we use that as a starting point for the board. Because it's got quite a lot of inputs and outputs, we can actually use that for lots of different controls. So the whole point with this project is it's a starting point, but what we wanted to do was allow for lots of other functions. So analog inputs for the rheostats or potentiometers that you might find on spinners, such as these on the paddles, and also plenty of other types of controls that may do other methods for detecting some of the other buttons. So the Mega Drive 6-button pad is a good example. It uses a clock serial shifted data that goes in and out and actually uses that to expand the number of buttons that you've got on the pad.
And possibly even controllers that we haven't even thought of, because it's pretty easy to update the firmware on this thing as an end user, isn't it? Yeah,
this really is a starting point. So we're launching this onto the market with a number of controls that you can just plug in and use. It's got a rotary switch on the front that you can use to select the mode. That switch can be reconfigured to do different modes and different controllers, and you may end up with multiple different firmwares for doing really exotic things or even custom things. So we intend to use this platform as a starting point for lots of other control systems, and some of those might be arcade controls, spinners, optical joysticks, all sorts of different things. And we've already had quite a lot of input from people that want all sorts of different controls covered as well.
Yeah, I want my flight stick and my throttle, please, Richard. I know flight sims aren't as big in demand as, say, a Super Nintendo pad, but one day maybe that will get to the front of the queue. And I should also say that the knob in the prototype version, this is the final version, but the prototype version was a Pac-Man. And Richard was very attached to his Pac-Man dial, but we thought maybe it might be testing the boundaries of copyright, so no more Pac-Man. You can print your own. You can
print your own. It's a fairly standard little D connection on there for putting that on. That knob was also the reason why this has taken quite a long time to get to market, because we had these on order and they took 9 months to arrive. We did do a design change to accommodate various other switches in that time, but we also couldn't get hold of those. So we waited and waited, and we finally got the knobs.
Right.
So the first batch is fully very expensive knobs, but they are very, very nice. They're very nicely machined. They work really well, and yes, they work great.
Yeah. So the board is available in 3 varieties, isn't it? So
yes.
Board only. So you might want to use it for your own project.
Yep.
3D print a case of your own or something like that. It's available standalone in this 3D printed case designed by Richard. You can buy the case with it, or the files are available online,
yep.
so you can download and print them in whatever colour you like. We're currently doing them in 2 colours.
2 colours for the
standalone.
CTRLDock,
so black, and this colour matched to the Amiga 500. So we've imported this from the US. It's printed solid filament. Colour match to the Amiga 500, and it is a spot-on match. If you put a 500 or a TV modulator next to it, it is identical. So that's available in 2 options. Exactly the same board inside, no difference. A couple of LED holes at the front here which light up. What do they signify? Power on one of them?
When they're connected in, and when they're connected to the computer. So
right.
So when you've got a device connected into one of the control ports,
Yeah. And then the third variety of this is what we call the slice, which is aimed, so keep in mind this is not specifically a multi-system or a Mister product. It supports your Pi, supports your PC, your Mac, everything like that. But if you happen to have a Mister multi-system, we wanted to make it so that it would integrate nicely. So that's where this case comes in.
Yeah.
And this just slots underneath the multi-system, which docks on top of it, and then it becomes a complete console again.
Absolutely,
with the additional ports.
That's right. So you can put one at the front and the back, so you could actually fit 2 on, or different versions in the future. And it just gives a nice little finish to the multi-system, or to any other compatible products that go out with that sort of form factor.
So those are the different flavors that you can get the CTRLDock Classic SE. That's what this one's called. It's to give it its full name. Yeah,
it's quite a mouthful. It will get cut down. The SE is really just to signify the knob in this first version, the special edition. So yeah,
gives us some wriggle room to give future versions different names.
We are just calling it the CTRLDock for now.
And then let's talk about what it supports. So D9, D15, we've got some examples here. Atari trackball, Analogue, obviously. The paddles, Analogue. The Atari 2600 paddles are 2 into 1 D9, aren't they? And
that's
it supports
right. Yes.
that. Yeah. We've got the Sega Mega Drive pad. Does it support the 6-button pad?
It does, yes. Supports 3 and 6-button pads, yeah.
2 players, both with 6 buttons?
That's correct, yeah.
Yep. The classic Amiga Tank mouse.
Yes.
And the Atari ST mouse, both supported.
A lot of them are very similar. The difference is really between the Amiga and Atari is, I think, the Y is just around the other way. So it's just different pins that need to be reconfigured. With the way we've got the electronic setup on here, we can basically make any pin an input or output and move the analog around as needed. So if there's a really obscure pad or a really obscure mouse or a really obscure analog device or a spinner, we should be able to make the firmware work for that.
And one such example, which I'll be honest, it's probably not going to be in huge demand, but we wanted to squeeze it in there, was the Amiga CD32 pad.
Yes.
What was special about that?
Yeah, that's quite a strange one. Different level voltages and also different ways of doing it. So I think our engineer Nick, who really threw himself into this project and was trying to get controllers from everyone, and we borrowed some Neo Geo controllers, we borrowed all sorts of different ones, found it really enjoyable to sort of just try and get all of these controllers working. I don't think we got a Jag one working in the end, but that's only because we didn't have an adapter to use for it. So once we get one of those, we can try and pretty much anything else that supports those controller types or can be adapted. That's the other thing. You can actually do a little wiring adapter outside to convert slightly different configurations of connector into those ones that can go onto that.
I'll keep going. Amstrad CPC joysticks, Sinclair sticks as well.
Yeah.
They're supported. Got the Sega Master System over there. Even the Atari 2600 keypad, which you would use with things like Star Raiders, wouldn't you? I think.
Absolutely.
Just looks like a telephone keypad. That's supported. Yeah. And as Richard says, pretty much anything can be added. If we know it exists and we can get hold of one to test it with, then we can update the firmware. Just talk us through the firmware update process, because it's so simple. It's worth people knowing about it.
Yeah, it's really simple, and a lot of this is the fact that it's using the Pico, and they've made that very simple for everyone to use. So all you do, you hold down the button, you plug in the connector, and it just looks like a USB memory stick on your computer. So there's just a drive with a couple of generic files that sit in there. You just drag the firmware over to it, and the second you do that, it disappears, and you think, oh, what's happened? But actually all it's done is it's reflashed the firmware and updated the SPI flash on the board. Everything's then done, updated. It takes literally about 2 seconds to do. So Good. That's it. So really easy to change if you want to. You could have custom configurations that you might want for specific things. One of the very first things we did when we were testing out the mouse connections was to put an optical trackable actual arcade one on there, and that just used the same Amiga inputs, and you can scale that how you want. So there's all sorts of different options you can do to get devices like that use optical inputs or spinner inputs.
And then when it comes to some of those analog inputs, there are certain sensitivity settings that you've added as well, haven't you, for the spinners?
Yes, because we had quite a lot of options on the rotary dial, Nick's put in some different settings, basically to give you more or less resolution with the spinners and the mice, because the old mice, especially from the Amigas, were very low DPI and they would move very quickly across your CRT screen. On a modern input, they go very, very slow indeed.
There's a lot of pixels on a 4K screen compared to an old Amiga CRT. If you're using Windows, you can whack the sensitivity up and there, and then it becomes perfectly usable. I mean, I'm not sure I'd want to use the tank mouse day to day.
No.
But then to dip into WinUAE, for example, and have a game of Lemmings, it's perfect. It gives you that really good, authentic feel.
Definitely.
What if I wanted to change the controller on the fly? Do I need to unplug the USB? Can I hot swap the controllers? How does it work?
You can. There is a setting for if you're going from one control to something very different, say from the standard Atari joystick through to a mouse that's using the different port and the different setting, you can turn it all the way to the 0 setting, and that will tell the controller to expect a change of controls. So that's the official way to do it, but actually it's more than happy if you just plug them in and you just turn it to the setting, and it will actually just settle down. It'll take a few seconds to identify the new control, go into the right mode, and set up exactly as you need. So yes, you can pretty much use this without having to keep unplugging it and that sort of thing. And
there is some built-in safety, isn't there, to stop us frying the board?
Yeah, there's quite a lot of built-in safety on there. There's overcurrent protection on the inputs and outputs, so it won't draw too much power. We're still sort of experimenting with controls that take power, so there are some modern controls that use Wi-Fi dongles that plug into the DE9s, and there we're still sort of refining those to work as best as we can with the traditional ports, the Mega Drive one and that sort of thing. There's quite a few available. So we've got to be a little bit careful though, because they do use a little bit more power than a standard port. And we are detecting how much power and allowing that much to go through. Other than that, yes, you've got a bit of protection on inputs and things being connected on the wrong port with the wrong setting. So if you put the mouse on and you've actually got it set to be an Atari joystick, it's not going to blow up.
Sure. Yeah. Okay, well, I've been splicing in as we chat here some examples of it in use, but let's see a few more because I've been having a lot of fun with this. So the first example here, of course, the first thing I grabbed was the Amiga Tank mouse. So here I am using it on my laptop in Windows 10, working fine, just like a normal mouse with those sensitivity settings turned up. And then I switched to the Atari ST mouse, a mouse I'm less familiar with, Richard, but I gave it a go. Are you a tank mouse or an ST mouse?
Obviously a tank mouse.
Tank mouse man. And then this is detected in Windows as a mouse, just as a normal mouse, and then the joystick shows up in game controllers in Windows and the equivalent in your Mac or Linux or whatever else. It's a HID, isn't it, device?
Yes, yeah. It's a standard human user interface device.
So you can use it just like any normal device, and you can see it here in Windows detecting the directional presses and the button presses, so that's all good. Then I had a little go on WinUAE playing Lemmings, Mark Fix's Stuff's favourite game. Here it is, working fine, and actually the sensitivity feels spot on for me. It's very responsive, it feels just like you're using an Amiga. Likewise with a Competition Pro joystick, straight into the D9 port to play a few rounds of Turrican 2, that was great. And then just to be slightly sadistic, here's an Atari mouse on Workbench in WinUAE. And then, so that was some experiments with the PC. Then I switched over to Mister using our multi-system, but of course it would work on any Mister system. And here I am using the tank mouse again in the Amiga core, the Mini-Mig core, playing a few rounds of battle chess and losing quite badly. Over here now is the C64 core with the Competition Pro again. And then just to mix it up, because you don't have to use the Amiga mouse in the Amiga core, although it feels right. Here's a Mega Drive pad being used in the ZX Spectrum core for a game of Bubble Bobble, which I know is one of your favourites. Worked absolutely fine. Feels like you're cheating a little bit using a Mega Drive pad in a ZX Spectrum. You need a slightly shonky joystick on a ZX Spectrum. In that instance, I was using the standalone control dock with the multi-system, which you might want to do because you could unplug it, move it over to your Pi, move it over to your, you might want that portability. Here are a few more examples of it in use. So you get the idea from those examples. We could go on showing you every combination of stick, but they work, and they work really well. It's great fun playing with these. Let's talk about latency, because that's a big feature of this, isn't it?
Yeah, it
How
really is.
How do we measure latency?
Yeah, so normally what you would do with latency testing is actually wire up the port you were testing into a device where you can actually have something that responds after the button has been pressed. So that's exactly what we did with our multi-system. We set up a FPGA core that we could have an output pin that would go high as soon as that's detected in the core. Then we can actually detect how many milliseconds or less there is between button pressing and that core being activated and knowing that the signal's there. Because this is all going through USB, there is a natural latency with the USB protocol. On the multi-system, on Mister, it is very, very low. So that is giving us an advantage already. You will get that benefit anyway with those systems, but you will also get a benefit from the firmware that we've written on this in things like Raspberry Pi or your PC or your laptop or Linux standard.
What's the lowest we've seen on this, the quickest response?
We've got to be a bit careful with that, because you can go very low,
right,
but you end up not debouncing your signals, so you end up having spurious signals. So the last thing you want is someone to be doing a platformer and it suddenly jumps on you, or it suddenly presses the button because it thinks it's got a signal because there's been a little bit of noise there. So there's always a little bit of processing, and that was true back in the day with the original systems. They all had to do that. But typically we're seeing around 700 nanoseconds, 0.7 of a millisecond, up to about 1.4 milliseconds, and lower in some cases as well. The highest latency is with the analog inputs.
Right.
Yeah.
So pretty good. I mean, compared to the 50 milliseconds of something like this.
Yeah, and that was variable as well. So sometimes it would be 50, sometimes it would be 20, sometimes it was even more than that. And actually, it's the variability that's very difficult for players to get used to. If it stays constant, you can train yourself to always have that little bit of delay. When it's jumping around all over the place, it's not very good.
So I did jump into our Discord server and ask if anyone had any questions just before we started the video. And the main one that came back was I've got one from Reese here.
Okay.
And he just wants to know, what's the main advantage or disadvantage of this over, for example, snack adapters in Mister?
Yeah, that's a good question. The snack adapters do work very well. They're very low latency and they work very well for each individual core. They are very specific to the core. So you have to have the Atari for the Atari core, you have to have the PlayStation for the PlayStation core, and you can't use those in the different cores because they are wired exactly as the core would expect to see them as real hardware. So pretty much like you can't put a Super Nintendo into a Atari, you couldn't do that with the snacks as well. So what we wanted to do is give people choice. And as you've seen, using an Atari mouse or an Amiga mouse on anything that looks like it wants to accept a mouse is possible with this, where that wouldn't be possible at all with the snacks.
Yeah, and you can also navigate the on-screen menus in Mister using this, which you can with your snacks. So.
Yeah, that's right. You normally have to have another control in place just to get those menu signals into the game, and then you can use the snack. Whereas this, it just works as a standard USB device, and Mister picks it up. The multi-system does as well.
And then pretty much every other question that I got was along the lines of, will this support controller X, Y, Z? Will this support the NES, the SNES, the PC flight sticks, etc.? So how do we address that question?
Yeah, well, we had to make some decisions on the actual physical connectors we put on the board. So they are D9s and D15s. So anything you can plug into that, we can explore, or you can experiment. The manual that's available does actually say what the chances are for any controls that we haven't looked at, and how whether they are likely to work or not. And by all means, experiment and let us know. We'd be happy to look at any controls that aren't currently supported in the firmware. Mm-hmm. And for things that have a different connector pin out, stay tuned. We plan to have future models of the controller dock that will have other connectors on.
Mm-hmm. Yeah, okay. And then I've just noticed this, Richard. This is a different size.
Yeah, it's quite a large one, isn't it?
What is this?
Okay, so whenever we create a control board or control system, we have to create a test fixture for it to be able to test all the functionality of our board. So Nick, the design engineer, decided to use basically the same principle as the control dock for the test rig. It's just a much more complicated version because it can move any point to any other point on the board, and it also has a really nice LCD screen. So we've done a 3D printed case for this, and actually a bed of nails that comes down. You put the unit under test, clamp it down, and it tests every single possible function, all of the analog, all of the digital, all of the serial clock data, and tells you whether it's passed or failed. And then we get a serial number at the end, which we stick on the bottom to ensure that they all work. But Nick has done a job of putting on faults onto the board to make sure they get picked up. And that's a very important part of that test process, to make sure things that shorts, open circuits, and cross wires, that sort of thing, that they all get picked up in the test fixture.
Excellent. Well, if you're interested in picking one of these up, there is a link in the video description. And also on that link, you'll find the current compatibility matrix, so you can see what joysticks and mice and the controllers are supported. But that will be subject to change as we continue to develop it and release new firmware for it. So keep an eye on that for updates and for future versions with different ports, adapters, etc. This is just the beginning, isn't it, of the control dock? Yeah. And keep an eye out for a few more announcements that will be coming up soon for our Mister multi-system and otherwise. There'll be a lot more chat about that. Yeah,
this is a very busy year for us in product development. We've got lots and lots in the pipeline and more to announce throughout the rest of this year.
Excellent. But remember, it's not just for Mister. It's for pretty much anything that you can plug it into. Yeah. So I hope this helps some of you to enjoy your retro gaming a little bit more, and go and check it out. Thank you so much, Richard.
Thank you, Neil.